This is a production of Cornell University.
Okay, so what I'm going to do for the rest of the week, I'm going to sort of change up a little bit, and we're still going to be doing sort of the lecture format. But what I'd like to do is we're going to talk about soil quality. And when I talk about soil quality is one of those terms. It's like water quality. What does water quality mean to you guys? What is when I say water quality, what do you think? Degree of purification. Anything else? How usable it is. Very related to the purification. Any other thoughts about water quality? What? Pathogens. You know, so some sort of measurement of usability, maybe. I mean, would that be a fair sort of? Oh. You guys don't have to read this one. This is meant to sort of transition us into sort of thinking about where we're going to be going in the future. But I'm going to be talking about soil quality versus water quality. But they're very comparable. If we think about water quality, we think of it sort of as a measure for usability. Okay? We'll think about that the same way you think of soil quality. Okay? What is soil quality? I mean, has anybody ever heard of soil quality before? If I threw that term out at you, what would you think of soil quality? What do you think soil quality is? People often have a little bit different interpretation of soil quality versus water quality. Okay, but in essence, they're really meaning the same thing. Water quality is sort of a measurement of its usability. Well, soil quality is also a measurement of its usability. The difference with water quality versus soil quality is that we generally use soils for a lot of different purposes. Okay? When it comes to water, we don't necessarily use it for a lot of different purposes that have different characteristics. We need to have a certain amount of cleanliness or whatever it is for it to be used, whether we're using it for drinking water, for irrigation, for industrial uses, for waste management. Okay? Those are what we use water for. Well, we use soil for a lot more different purposes. Okay? So, let's think about issues that we are going to be facing, and I'm premising this under soil quality, but for today, we're basically going to be talking about what are we going to be facing in the world. Okay? So let's sort of set the stage. Okay, and we're gonna put this under two rubrics. One is the soil quality rubric, but the other one is food. Okay, so setting the stage, let's talk about population. Okay, world population. This is 1950 to 2050. The blue line represents population increase. The arrow is indicating about where we are. I guess maybe more 2013, but you know, population almost 7 billion people in the world, right? Am I wrong? About 7 billion? Yep. Last year, so the line's wrong, not me. So we're about 7 billion people. Okay? Now, if we think about where those people are, though, there's a big distribution change across the planet. Okay? Let's take a look at this one right here. Down at the bottom, we're basically looking at the developed parts of the world. Pretty flat lines starting about the last decade. Okay? Right here, this is Latin America. Coming up into China, a fairly large boost here. The one-child policy. India, fairly large boost as well. Other Asian countries, huge boost. And then Africa. So the big part of the increases are really India, other Asia, and Africa. Okay? Now, if we think about where these people are living, not just regionally, but sort of in relationship to density of population and things like that, you're really looking at urban versus rural. Okay? These greener, darker lines down here, these are the more developed world. You're basically looking at an increase in the urban population starting probably around in the 1950s, 1960s. Okay? Where the vast majority in the developing world of the population were in urban environments. Okay? So I think maybe 2 or 3 years ago, when you looked at the world population, 50% of the world population at that point were now living in urban environments. Okay? In the developed world, that was a long time ago. Okay? So if we look at something right around here, you're splitting urban, rural, rural. Right around here is when 50% split happened. Okay? Now, the interesting thing here to look at is if we look at the low-income countries versus the high-income countries, that split is the same as in the urban, as in the high-income countries, but look at the amount of population. Okay, so that's setting the stage one. Setting the stage two, we already set. We talked about this, I guess, a week and a half ago, but we're looking at soil degradation. Natural resources, if soils and landscapes are where we're going to be producing our food and where people are living. Now, granted, we do harvest a lot of food from the oceans, but there's not a lot of people living in the oceans. Okay, we're looking at sort of landscape degradation here. Okay, we've already talked about this one, so we'll skip over this one. Okay, the next thing to consider, if we're talking about food, where is the food being produced? Okay, now these are basically, and if most of the food is being produced on land, and it is, food, fiber, and fuel is mostly on land, where does that land, where are we counting that land? These are the climatic zones here, so we have polar, subpolar, cold temperate, cool temperate, warm temperate, and tropical. Okay, this line here basically tells you of the millions of hectares that are out there, how much of that is arable. Okay, and then of that arable, what's grazing, what's non-arable. Okay, so potentially arable. When we say arable, we're really meaning sort of under the plow type of stuff. Okay, so crop production. Okay, then grazing, you really can't put the plow in. You can't do crop production, but you can have animal operations. And then non-arable basically means nothing. Okay, does that make sense? Okay, and if you look at the climatic zones, it totally makes sense. I mean, the cold regions, you're really not looking at a lot of arable activity. When you get down to the tropical regions, you know, the total land area is basically, almost all of it is really arable in some sense or another. Okay, now the interesting thing here is that it should be noted that we're also looking at this difference between what you would think of as sort of food coming from plant material versus food coming from animal material. And as you move farther and farther south, you see an increase in that, or a decrease, I should say, a decrease in the grazing percentage of the total. Does that make sense to everybody? Okay, so there's a good chunk of this world that we can have agricultural operations, but we can't be growing tomatoes everywhere. And that's often a hard message for people to take. The thought is, well, if we took all of the land that is arable and put it into vegetable production, we'd be able to meet, you know, all the nutritional needs of everything and everybody and so on. But the reality is that a good chunk of the planet, we can't grow tomatoes. So you have to think about what type of crops you can grow, and if you can in fact grow crops, or you have to go to some alternate form of agriculture production, which is primarily animal production. All right, so we've got three things to think about. First is we've got population pressure. Second is we have land issues. And third is we have specific locations in the planet that we can only grow certain things. All right, so let's talk about what's happened, and then we'll start talking about what potentially we can do. Okay, so this is basically an increase, basically looking from the early 1960s to the early 1990s. This is dated material. Okay, but if we look at regions and we look at the increase of food. Okay, so if we go back, I haven't showed this slide yet, and I'm going to hold off on this. But think about this. If we are going to increase production, food production, there are basically only two ways we can do that. What are those two? I mean, the answers are right there. What are the two ways that we can do that? First way is we can literally increase the amount of area that we're farming. Okay? The other way is we can increase the amount of food that we are growing on every square foot. Okay? So we can increase the area or we can increase the yield. This slide basically represents the increase of food that is attributed to each one of these areas. Okay? So if we look at sub-Saharan Africa, 47% of the increase in food is basically attributed to an increased area. They're increasing their growing area. 52% of it is attributed to an increase in the production of that area. Does that make sense? Okay. The interesting thing to see here is basically look at this half versus this half. And South Asia is sort of in the middle. But down here, East Asia, the high-income countries, huge chunk is due to increased yield. Now, this is partially reflected by the Green Revolution. Actually, partially, it's majorly reflected by the Green Revolution, increased use of fertilizers. Okay? The numbers that you're seeing up here, still the vast majority is due to increased yield. But a good chunk of it is also this increased area. Okay, so we got population, you got land degradation, and we have this issue of where or what you're growing. So this chart right here is basically looking at India. Okay, this is the entire world, but this is India. If we take a look at this, if we're looking at this component here, increased area versus increased yield. If India had not had increased yield from 1960 to basically 1993, this line right here represents how much land they would have used or would have had to use if they had not increased yield per hectare. This line here represents the amount of land used to grow the food that they are today. All right? Very interesting juxtaposition if you think about this issue of I only have two options to increase my yield. One is I increase my acreage. Two is I increase my yield. India is a very good example. Now, at the same time as we've seen this, up until the mid-90s, now this has changed since then, the yield has increased and the price has dropped. Now, we could argue this. Now, we know something that when this chart was made, they didn't know. We know what's happened since then. Okay? But an argument could be made that the main beneficiaries, and I say it right here, the main beneficiaries of this price drop is basically the people who put more of their money into food. Okay? If you look at the entire amount of money that you have and the percentage of it that you put into food, who are going to benefit the most from the price drop? Now, this is the argument. Who do you think? The people who have less disposable income. Does that make sense? Okay. Now, what has happened? Actually, this kept going down for about here. But what's happened around here? Has anybody been keeping around 2005 and 6? We had a couple of prices doing this. Okay. Now, there's been a lot of arguments as to why that's happened, but yields have continued to increase, but they haven't been as dramatic as this. But prices are starting to do this. They're not coming down as they were. Okay. So something to think about. Other things to think about. The majority of agricultural development in developing nations is based on traditional agricultural practices. And these traditional agricultural practices were very, very successful. The problem with these agricultural practices is that we're starting to see things like this. Now, look at this. This is the fertility level of the soil, and this is the years of cultivation. Okay? These years, these light green years, are basically cultivated years. These dark green years are basically the years where it's fallow. Okay? And traditional practices, you leave the field fallow for, in this case, they're looking at 7 or 8 years here, and then you harvest for a couple years, and then you let it go fallow again, let the soil fertility come back up. Okay? You'd have, in many cases, up to a 20-year fallow period, if not longer. Okay? Now, traditional, this is a Swidden technology, and there's lots of other traditional methods. Okay? Okay, does everybody know what Swidden technology is? Swidden, slash and burn, where you basically would go in, you'd cut the forest down, you'd burn it, get the fertility of the burn material into the soil, then you'd farm that land for a little bit, and then you'd abandon it, let the natural forest take over again, bring the fertility back up, and then you'd come back in and cut it again. Okay? That fallow period was that period where you would abandon the land. Okay? Now, this is what we're seeing today, though. Why? We need to increase more food. It's one of those 3 things that we talked about earlier. We need to increase more food, but because our populations are growing, we can't let these soils, at least using traditional methods, we can't let these soils sit in the fallow period as long as we did before. This was extremely sustainable. This is not. Because what's happening, as this line goes down, it's not like I'm getting the same amount of production each year during the harvest period. I mean, my soil fertility is going down. If my fertility goes down, my production goes down. Does that make sense? Yep? Okay.
This has been a production of Cornell University, on the web at cornell.edu.